Okay, hello, my 130s. So this is actually homework alternate chapter 6. Let me put it over here. Chapter 6. This is the fourth part. I'm going to start from number 31 and just keep going till as far as I can get in the time that I'm allotted. And I'm just going to do the odds to speed it up. Okay. All right, so let me go ahead and clear that so I have some more space. Okay, so 31 is first. For this, what I want you to do is kind of think about what if we let x be equal to square root 2, and we let y be equal to square root 3. Then look what happens to this part here. This would become 4x minus 9y times 6y plus 3x. Hopefully you remember how to distribute that. That is chapter 4 stuff. Essentially, we would want to FOIL. First, last. Sorry, first, outer. Bad me. First, outer, inner, last. Okay. Okay, so I'm not going to do it that way. I'm actually going to still FOIL with what we have here. You could test this and follow along. It should still work out when you simplify, but let me clear this out. Okay, so basically for this, we're still going to use FOIL. So from the first part, I would suggest writing it all out the long way first, unless you're really comfortable with this. Oh, hold on, my cat's about to jump on my printer. Let me pause. Phew, okay, crisis averted. All right, so the first thing we are going to do, we're going to take 4 root 2 and multiply that by 6 root 3. Okay. Then we have 4 root 2 times 3 root 2. Now we have, okay, come on, no. Oh, 1 second. Okay, sorry about that. Let's try this again. She fell in a box. All right, now we have 9 root 3 times 6 root 3. And lastly, we have 9 root 3 times 3 root 2. Let me move this over. Now, what we're going to do is see what are we supposed to do with these. Okay, so note I left the sign off too, quote unquote, for the 9 root 3. Not exactly. Essentially, if I were looking at the first term, that's a positive times a positive, it'll come out positive. The second term here, that's positive times positive. We're going to put an add sign in the front. This third term, we have a negative times a positive, so this will become a negative. Last term, negative times positive becomes negative. And then essentially what you're going to do, I'll do this off to the side for each of these terms. So 4 root 2 times 6 root 3. We're going to multiply the coefficients in front, the 4 and the 6. Okay. And then we're also going to multiply the root 2 and the root 3. Now this part becomes 24 in the front, and then you can put the root with a 2 times 3 underneath. So this is 24 root 6. Okay, you can see that there are no pairs of factors here, so this will not be simplifiable. Keep it 24 root 6. We have a plus in the middle, and let's keep going. Next, that would be 4 root 2 times 3 root 2. That's 4 times 3 times root 2 root 2. Okay, that's 12 root 2 times 2, which is 12 root 4. Now, you see a pair here, right? So it's 12 times 2 simplified, which is 24. Keep going. Put your negative sign. I'm going to go a little bit faster here. Let's do this in orange. So 9 times 6, 54. And root 3 times root 3 is actually going to be 3. Okay. So what that turns into would be 162. And then we have another negative sign. 9 times 3 is 27. And then root 3 times root 2 is root 6. Now this is when you go back to adding and subtracting radicals. So the terms that will be like, you have your root 6 terms, and then you have your constant terms. So let's start with the constants. We have 24 minus 162. That'll be negative 138. And then we have 24 minus 27 of these root 6s. So that's negative 3 root 6. $31 is done, son. I'm going to go ahead and clear this out. The video, you'll be able to pause it and write or take pictures of whatever you want. Number 33 is next. Let's hope this doesn't mess up when I try to move it. Okay. So 33 is really interesting. It's not a question I'll be asking you on your tests, that's for sure. So basically, for this one, you have to remember that these indices are different. So you can't just put them on the radicals, sorry, the radicands. You can't put the radicands under one radical sign for this, okay? Instead, you're going to need to use exponents to help you out here. So let's make the top orange. Let's erase this first. So top will be in orange and the bottom will be in blue. So for the top, we have C to the 10th, D to the 3rd. That's all taken to the 1/4 power. In the denominator on the bottom here, we have C, D to the 1/3. Next step, you can separate. That's going to be C to the 10/4, D to the 3/4, divided by C to the 1/3, D to the 1/3. Here's where you use your exponent rules. So you're going to have C to the 10/4 minus 1/3 for the power. And then you're going to have D to the 3/4 minus 1/3 for the power. So for this part, you can just use a calculator for it, or you could actually add the fractions up. So that's going to give me C to the 13/6 and D to the 5/12. Okay, now the next strange thing is you want to write this all under one radical sign. So let's put that in pink. At most one radical. That means you want to get your index to be the same. So use LCD. LCD between 6 and 12 is 12. So we're going to keep D to the 5/12 as it is. We're going to change C to the 26/12. Okay, that's the same thing as C to the 26th, D to the 5th, all to the 1/12 power, which comes out to the 12th root of C to the 26th, D to the 5th. Now, unfortunately, we're still not done with this particular problem because we can simplify the C to the 26th. There is a perfect 12th in here, at least one. Let me erase this. And drag this up. Okay, so this step we have 12th root. C can be broken into 24th power and 2nd power. And you have D to the 5th. 24 is divisible by 12. Goes in twice. So that becomes the exponent for the stuff outside the radical. And then the 12th root, you still have C squared D to the 5th. So that one's a more involved problem. If you struggle still with simplifying radicals, I'm going to put up a video on YouTube about an activity for that. And I should have that up tonight. $35 is next, rationalizing the denominator. So for this one, that means you want, do not want any radicals in your denominator. Okay, and there's actually going to be two ways that we deal with this. Let me see if I can scroll here. So we're going to actually look at both 35 and 36 for this, because these are the two ways that you can do it. One is if you just have a single radical underneath the, sorry, let me repeat that differently. So case one, you have one radical in your denominator. Okay, and then the other one is you have multiple radicals added or subtracted. So this part here is a monomial, and this is a binomial in this case. All right. So let me clear all this out. Sorry, it's case two. All right, so for number 35, I'm essentially kind of think, how can I multiply the top and the bottom of my fraction by something that turns this 5 into a non-radical item? Well, multiply radical 5 by itself. And then on the top, you have to do the same thing. On the top, you get 3 root 5. On the bottom, you get 5. All right, I'm going to clear that one out because the next one's a little bit longer. Number 36. For this one, we need to introduce the conjugate of a factor. So if you have the factor a plus b, its conjugate is a minus b. Purpose of using the conjugate, you can multiply the factor times its conjugate and get rid of middle terms. This would be a squared minus b squared. Okay, so gets rid of middle terms. Do note you'd have to FOIL this out. This would be a squared plus ba minus ba. Of course, another distraction. Okay, a squared plus ba minus b squared. And then that's what I mean by the middle terms cancel. Okay. All right, so essentially, we have root 11 minus root 3. Its conjugate will be root 11 plus root 3. So we're going to multiply top and bottom of our expression by the conjugate of the denominator. So this is what we currently have. And this is what we're going to multiply by. Top, bottom. Now it's really going to help you to, you have multiple terms, right? So this is a factor, 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 factor. So I suggest putting parentheses around that. If you're comfortable, you can go ahead and start foiling. You foil the top and foil the bottom, but if not, just write the factors you have to multiply again. Okay, so foil, foil. Okay, and then on the top, we get a 3 root 11 times root 11. That becomes 3 times 11. And then we have 3 root 11 times root 3. That's plus 3 root 33. From here, plus root 33. And from here, plus root 3 times root 3 is positive 3. On the bottom, be mindful of your signs. You have root 11 times root 11. That's 11. We have root 11 times root 3. That's plus root 33. We have in the middle here minus root 33. And then we have minus root 3 times root 3 is 3. So this is that canceling of the middle terms from the conjugate. Now you have no more radicals in your denominator. Simplify where you can. This part here is 33. So 33 plus, you have 3 root 33 plus 1 root 33. That's 4 root 33. And still a plus 3 here. Bottom 11 minus 3. So that gives you 36 plus 4 root 33 divided by 8. So we're still not done with this problem. We have to simplify this by factoring. Okay, and then on the bottom here, 36 and 4 have 4 as a GCF. So we're going to factor 4 out, and we're left with 9 plus 1 root 33. We can factor out the same GCF from the bottom. 4 cancels 4. We have 9 plus root 33 over 2. Let me go ahead and clear this out. Let's move to the next page. Not that one. Okay, 37. Oh, I guess I could have just done this one with the conjugate. Oh, well. I'll move on to number 39. I think actually I'll do number 38 too for this. It'll be a little helpful. So we'll start with 38. I wish I had more room here. So number 38, we want to solve for x here. So you need to note that you need to isolate your radicals on one side. Essentially, once our radicals are isolated, we can undo them with an exponent. So isolate radicals first. So first thing I'm going to want to do with this particular problem is add 1 over to each side. Then I have 3 equals root 5x minus 21. This is a square root. So we need to square it to free the radical, sorry, the radicand. So here's my radicand, right? I'm trying to free that guy, and in order to do it, I have to square both sides. So let me do this in a separate step. 3 squared. That equals, you have root 5x minus 21. We're going to take that and square it. So on the right side, we get 5x minus 21. And on the left side, we get 9. Going to add 21 to both sides. We get 30 equals 5x. And then we divide by 5, both sides. So then we have x coming out as 6. For chapter 6, must check solutions in original equation. As a matter of fact, this is pretty much for chapters 5, 6, and I believe 8. You must check your solutions to make sure that there are no domain issues. So I'll do this check out. So 2, does that equal root 5 times 6 minus 21 plus, minus 1. Okay, so 2, is that equal to, we have over here 30 minus 21 under the radical sign, minus 1 outside. 2, is that equal to, we have 9 under the radical sign, -1. Keep going. Works out. Okay. So x is equal to 6 in this case. Okay. Now, let me clear this out. Quick side examples. It's just to show when we would get a no solution out of this. So if we had, let's see, square root x equals 8 and square root x equals -8. We're going to look at both of those. So for problem 1, square root x equals 8, we're going to square both sides. And then we get x equals 64. Now we check, does square root 64 equal 8? And yes, 8 equals 8. So this actually would be a solution. For number 2, square root x equals -8. Hint, hint, can't happen already, because how do you take the square root of a number and get a negative number out? Okay. So we're going to square both sides. We actually get the same looking equation, x equals 64. So then we check. Is square root 64 equal to -8? And the answer is no. Remember, square root 64 is the positive square root. That's 8. That is not equal to 8. So for this case, it would be no solution. All right, let me clear this out. I'll go ahead and go to number 39 next. Square root 2y plus 13. Actually, I'm not going to write that whole part again. What I'll do is this. Remember, you have a square root on both sides now. Essentially, that means both your radicals are isolated, so that's great. So we're going to square both sides. And that'll be the first step I write. It's 2y plus 13 equals 5y plus 7. So solve for y traditionally. I'm going to start by subtracting 13 from both sides. 2y equals 5y minus 6. And then we're going to subtract 5y both sides. We have a -3y equals -6. Divide by -3 both sides. Y equals +2. I'm going to do a quick check here in my calculator. If you take square root of 2 times 2 plus 13, it actually comes out to, let's do the check in red, root 17 on the left-hand side. If you take square root of 5 times 2 plus 7, it's root 17. So this one does check out. Save. For number 40, I'm going to still leave you guys to work that one out on your own, but hint for number 40, you actually can't completely isolate the like both radicals at the same time. So what you want to do, go ahead and square both sides here. The right side will look decently nice here when you're done with that. The left side, you're actually having 9 minus root x squared, right? So you're going to need to FOIL. Then you need to isolate your radical again. So repeat the process of isolating the radical. Let me clear this out. Um, 42, one thing I want to say about that one, I'm not going to ask you one like this on your homework, sorry, not your homework, on your exam because it's a bit longer. Again, it's the same thing where you can't isolate one of the radicals, but when you repeat the process for number 40, it gets pretty long and tedious. Let's go over number 41. Number 41, you already have your radical isolated. So your first step, it's a square root, square both sides. So we're going to get u squared equals 2u squared minus 8u plus 15. Solve traditionally for u. Remember, this is a quadratic. So we want to get all of our u terms to one side. So 0 on this side. We've subtracted u squared both sides. So u squared minus 8u plus 15. And then from here, you can use AC method to factor if you still struggle. 1 second, cat nonsense again. Okay, let's see if she'll let me get through a little bit more here. Okay, so new u, 15, 33, and oops, 5. And then I need a -8, so minus. That's trial and error method, which takes some user practice. Don't use it unless you're comfortable with it already. Okay, and then from here, you need to use zero product property. Remember, that's stating that each of these factors can individually be set to 0. So u minus 3 equals 0, or u minus 5 equals 0. So u comes out to 3, or u comes out to 5. Now let's box them both for now, but we also still need to check in the original equation. So when u equals 3, I'll do this in calculator. We would have, erase this step real quick. Actually, I want to keep that. So we're going to be checking in u equals square root 2u squared minus 8u plus 15. So we have square root 2 times 3 squared minus 8 times 3 plus 15. Okay, so that's going to give me 3 on the left-hand side, sorry, on the right-hand side. So when I plug in 3 here, I get 3. And then when I plug in 3 for u, this one does check out. When u equals 5, we can see that the left side will be 5. Let's check what we get on the right side. we get 5. So they both work in this case. Okay, let me clear all this. Let's see. I think I can get through a little more of this. 43, solve the following equation for E. So for this one, you're just going to treat the N like another constant. You're trying to solve for E. So first thing you're going to want to do, you need to get the 4E outside of the radical. So we're going to square both sides. N squared equals 4E. And then we divide both sides by 4. And we get N squared over 4 equals E. Save that, clear it. I have 1 page left, or 2 pages. I'll wait on these ones, actually. So that'll wrap up part 4 for right now. I got to number 43. Okay, so the rest of the week I'll finish this up with the LAC 130 group, and then the PCC 130 group. You should have your videos for the whole thing by then, but I'm still going to be here during our regular Zoom session for you to ask questions, or if you want to practice with me, I can give you some activities. All right, so look out for some messages and emails from me soon, and I will see you guys later. Study up.